G'day, this is Peter Folsom from Zumasys, here ready to make BASIC great again. But in all seriousness, I'm going to be covering ways of extending BASIC and mixing other languages, as well as looking briefly at our new language, JavaScript. Firstly though, isn't BASIC great already? After all, there are thousands of apps around the world still being used and modified in BASIC. I remember way back in the day when all we had was a query language and PQN procs. And then along came a guy called Ken Sims, and he created a programming language called Data Basic, which is a bit of a shame. Not that he created it, but that he called it BASIC, as it's much more than BASIC. When you compile BASIC programs in JBase, they first get converted to C and then compiled into object code. So you could, if you wanted, just write C code and use the JBase APIs. But that would take way longer and for the most part get you into a world of trouble. That's why we have a BASIC language, to get the job done quickly. You may be interested to know that the majority of JBase commands are in fact written in BASIC and at various points called JBase APIs. JBase makes calling an external C API relatively easy, certainly compared to other multi-bay platforms. There's no rebuilding of any kernels or JBase runtime. You're simply compiling a new executable and possibly building a shared library and add that to your environment. So it's very easy to extend. Maybe instead of a C function, you'd like to call a Python subroutine? The question of learning C, if you don't already use C, is a daunting prospect. As I mentioned, you could use Python instead if there was something you wanted to do that BASIC couldn't handle, or perhaps you already had some Python code you wanted to use. But what if you have a C library or some C code that fell off the back of the internet and you want to incorporate that into your BASIC application? For the C versions out there, I recommend first taking a BASIC program, not too big, perhaps write a new one and add some displays and prompts, call the subroutine, just a few bits of sample code. Make sure the program has a .b extension, rename it if necessary, then use jcompile-s to interim compile into C and have a gander of what the code looks like. I'll show you an example shortly. But if you're a fair dinkum C programmer, and by fair dinkum I mean rigididge, and by rigididge I mean proper. So, as I was saying, if you're a fair dinkum C programmer, you wouldn't take the generated C code from a jcompile-s and run with it. It's just a useful way to see what JBase APIs are used in different situations, and also get an idea how you might wire up a non-JBase API, or possibly an existing one. Because BASIC code gets converted to C, you can compile a mixture of BASIC and C in one step, as long as the BASIC code has that .b extension. One thing to note about the .b extension, when you BASIC programs with .b, you will end up with a .o or .obj extension object code instead of the old style $prefix file. Let's have a quick look at jcompile. So here's a simple program that just displays a string, inputs a variable, uppercases it, and uses it as an indirect call subroutine method. Compile that into C code using jcompile and -s for the source. The -s means compile it into the C source. So here's the resulting C code. Notice there's an include to sample.j. This is used to store constant strings and various other variables used by the C code. The rest of the BASIC code converted into C is a series of function calls, pretty much. So here's our prompt, our CRT, our input, our uppercase. Here's the call, the indirect call to a subroutine using the value of what's in SUBR. To call a C function from BASIC, you need to declare the function with the arguments expected. There are two commands that facilitate this, defce and defc. The simple explanation of the difference is that defce only supports string, int, and float, and by string I really mean char star pointer. defc, on the other hand, supports regular BASIC types. Here you can see a method using JavaScript. I'll get to that in more detail, but the code to pay attention to here is the curl setoff function call, which is a regular C API from the EasyCurl library. Here's an include with a bunch of basic function declarations and also defc functions. Notice that jcurl setopt has a var, int, and var, which is then used as a gateway to the original C function curl setopt, which had char star, int, and char star respectively. And here's an example of one of those basic functions from the defn. In some cases, it makes sense to use a defc wrapper function that calls a regular C function so as to handle the back and forth between basic vars and regular C variables. Here's an example of the defc function jcurl_init, which is then calling another C function storecurl, which is used to store the curl instance pointer. This in turn calls a generic function called storePointer, which is where the actual pointer storing occurs. The more important difference is that with defc, the arguments you pass, typically being var types, are basic, i.e. basic variables, can be modified in the C function, whereas passing string or char star pointer prevents this. As Tony Montana was suggesting in the previous slide, jcompile is extremely powerful and versatile. It can compile BASIC, C, and Java, a new hybrid language, as well as linking object code to an executable. As it's a JBase command, it's designed to do the right thing on the platform on which you're running JBase. So on Windows, it will use CL and link. On Linux, it will typically use GCC or CC and AX, XLC. But as JBase is heavily environment variable driven, you can even change the underlying compiler by setting an environment variable called CC. We don't normally recommend that, but there may be extenuating circumstances where you wish to use an alternate C compiler. A new alternative to defc and defce is to use our new Java language, which is available in JBase 5.7. Java blends basic and object-oriented programming and additionally lets you inject C code right in the middle of regular basic. Let's have a look at an example. Here's a copy of FTP upload.c from the EasyCurl website, and I've converted that to Java code. So here I've added a hash header at the top. The rest of the C code is the same. I've commented out my hash defines there. Callback stuff is still the same. Here's the hash end header. And now this is regular basic code. One thing that's worth noting is that it is easier to work with basic variables and mixed JavaScript and C if you just use uppercase variables with no punctuation. Down here on line 99, I've got a hash in line, and this is basically the start of the original C code from the FTP upload.c. And on line 18 to 113, or rather 108 to 111, the original hash defines converted to char stars, and here I'm converting them, the basic variables, local file, upload file as, remote URL, rename file to, and also buff1 and buff2. They were originally static char stars, and now I'm supplying them with variables from a basic program. As we scroll down the code, this is all C, directly taken from the example, until we get to this last bit on 181, where I'm returning the original buffer that was returned by the FTP upload program, and storing that in my callback buff variable. And then down the bottom, I'm displaying callback buff. So recapping on Jabber and C, you can still use basic and catalog. You don't have to use jcompile. It's totally up to you. Use the hash header and n header for including headers and declaring C functions. Use hash inline for injecting C code, and use hash var append to avoid sequential numbering of variables if you're coding a multi-method class. A good example to try is using the libcurl from EasyCurl website. The first thing to do is to install curl-devel. In this example, I'm suggesting to use yum. That's if you're using a certain flavor of Linux. You can also download directly from Windows, and there's an AIX download as well. The FTP upload is a nice example to test, and you can get it from the example section on the website shown here. Bear in mind that many of the examples will have hard-coded URLs or other user password details, so you may have to make the odd cosmetic change here and there. One other detail of the FTP upload example is that it has a remove command which will fail if there isn't a matching file to be removed. So if you're working with this example, you may need to create a fake file to be removed or comment out the header command that issues the removal. Here I've got an example of compiling that sample FTP upload code. The -r there tells jcompile to not include the main function that it would normally include when you compile a basic program, because the FTP upload already has a main. The -o is just telling what I want to call the resulting runtime. FTP upload.c is obviously the C code. And because it uses the EasyCurl library, I'm adding a -l to link in libcurl. You don't use the word lib when you're linking in, you just use -l followed by whatever is after the word lib. So here I'm making a copy of the FTP upload code and calling it ftpupload.jabber, which is the sample code I showed you earlier. Just going through this again, we have a hash header at the top. I've also included jsystem.h just for demonstration purposes. You don't need that in this case, but normally if you are writing a C code, you would include jsystem.h so you can access all the JBase APIs. The original FTP upload had a bunch of hash defines, which I've commented out because I want to be able to programmatically populate those variables. At the top there, I've created a macro called getCFB, which basically runs the conv SFB macro built into JBase. In the middle there, I'm using the original hash define variables, building up buff1 and buff2. But these are now basic variables, so we can prompt for them, do whatever we want. And then you can see down there on line 3072, I'm assigning the local file char pointer, which used to be a hash defined static string. I'm converting that from a regular basic variable into the C variable that is expected in the original C code. Here's another example of the header declaration or header declaration that you might have in JavaScript. At the top there, I've got the hash header, and then I've followed that by a hash if and def Now, the next thing can be whatever you want, but typically if I'm writing a Java class called, let's say it was called Python, so it'd be J class underscore Python underscore defined, then hash define J class underscore Python underscore define. And the reason that we need that is if you're writing a Java module with multiple methods and you use a C structure or various other C declarations, this header will be included in each class method, and you'll end up with duplicate declarations if you don't do this hash if and def hash define. So it's good to just get into a habit of doing that. Here's another example. At the top there, it's Java, regular JavaScript or basic code. Then we have hash inline, where we're calling C functions directly and manipulating C variables. Then in the hash endlined, we're back into basic code. Temp equals empty stream. FC is a decount of paths. And then we've got a for loop where we're setting path equals paths attribute F. Then we're back into C code, where we're referencing, we're re-referencing the download variable because the hash inline at the bottom doesn't know about the hash inline at the top. So in the top part, we've declared buffer struct download, and we store it using store pointer from buffer struct into a variable called download. And then in the second hash inline, we retrieve that download using get pointer for buffer struct. And the download variable, which is initialized at the very top of the screen, you can see in lowercase download, that enables us to persist C pointers from one hash inline section to the next. So what about other languages? JBase can already call Java using call J. And what about Python? To the Java-mobile. So I have a couple of bits of code to show. This is taken from a YouTube blog that showed how you could call Python from BASIC. Here I'm picking up the latitude and longitude variables from the sentence. There's some comments here on an example to try. On line 21, I'm instantiating an instance of my Python class, which is also written in Java. And I'm assigning that to a variable called pyobj. And now I'm saying distance equals pyobj call sub, so that's a call sub method. And I'm asking it to call the Python code distance between points, passing in these arguments, and then displaying the result distance. If we want to look at the Python code, this is, again, just grabbed directly from the internet, fell off the back of, so to speak. And here's my Python class. I include jbc.h. In a lot of code I do that because it has a bunch of variables that make things portable from Windows to Linux, various other static functions which are useful. Here's my hash header if and def defined so that anything declared in this hash header section doesn't get duplicated. There's a bunch of other macros that I put in here just to make it easier to get things in and out of basic variables and into C objects. Here's the constructor for my $Python class. Note you don't have to call your classes $. They can be whatever you want. I just call it $Python to make it stand out. And it expects a module argument, which in the demo case is going to be distance. I'm using the var_append construct so that any basic variables that I reference will get appended with construct. And the reason that we do that is because if you have a variable that you use in multiple methods, so like constructor, destructor, call sub method, if you reuse a variable, it'll get a sequential number unless you use var_append, and that makes it easy to find. So, for example, py syspath will be py syspath underscore construct. Here's the destructor for the class. One of the cool things about Java is that if you reference an instance of a class, then the destructor will be called when your process dies, your JBase process wraps up, unless you actually close the object yourself, which is a useful way to have a final bit of code running in your basic application. The parse module is used to find out where the Python library is and to set up the include path for calling Python routines. And then here's the actual call routine. Notice the call sub doesn't have any arguments, and instead I'm using the built-in Java class called $vararg, which works a bit like the args array in C, and that means that I don't need to worry about how many arguments are coming in, because if I'm calling a Python subroutine, I may not know how many arguments are going to be. So this bit of code is going to work out that for me. I'm not going to go into any more detail about this. If you want to see more about this Python code, come and see me after the show. Actually, in all seriousness, we will be setting up a zumasys.com/utilities or utils website. More on that later. If you have any questions, visit docs.jbase.com. As I mentioned, we will be having a utilities page for downloading all sorts of cool things like the Python module and various other tips and tricks.